Afternoon. The today's test is this percentage regulation determination on the three-phase alternator. The alternator ratings are here given, and the prime mover ratings and the DC shunt motor ratings are given here. In this test, we are conducting the three types of experiments. The first experiment is open circuit test, and second experiment is a short circuit test, and third experiment is a combined test. So this is a combined test we are conducting. The aim of this test is nothing but to determine the percentage voltage regulation of the alternator by ZPF and ASA methods. These two circuits will give for the ASA method testing, and this is for ZPF method testing. So we will see that how to calculate the percentage impedance using ZPF method, in the sense that is by drawing this Poitier triangle from the readings obtained from this test. So we need to draw this graph based on the test measurements here. So that let us proceed. First one. So for these two tests, you just refer the video which I recorded for the percentage of regulation using EMF method, that is synchronous impedance method. This is most similar to this the test, and we can also able to get these two table readings, open circuit test table reading and short circuit test table reading, just like the EMF method what we proceeded in the previous reading. Please refer that. And in this experiment we are additionally conducting the ZPF test, zero power factor test. So this is what is a combined method of testing both open circuit and short circuit. Here the alternator, the end phases is going to be connected to the inductive load, highly inductive load, and in series with one of the phase we are placed one ammeter. So in order to measure the short circuit current, and between phase and neutral we connected one voltmeter in order to measure the phase voltage. So this phase voltage is common, right? Next, the procedure for determining this experiment is nothing but, here we have a prime mover. The prime mover is controlling the alternator. So the alternator is connected to the load, and the field of its alternator is connected to the DC supply. This is the excitation for the alternator. Once you vary this excitation by means of the rheostat connected here, so the current through this field field winding is going to vary, so that this field current is measured in this ammeter. So this setup already connected here. So you can see that setup. There are two rheostats. This is one rheostat we connected for the DC motor. It's a prime mover to control its speed, and this another field rheostat we connected in the field of the series with the field of the alternator in order to adjust its field current. And this three ammeters are there. One ammeter is in series with this field winding, and one more ammeter we connected here. It is connected in phase of. So this is the position. This in phase of alternator, and this voltmeter is connected across a phase and neutral. So this is a circuit setup it is made, and here we can see that the inductive load here which is there, and that inductive load here is connected across the phases, three phases. So that we have the circuit setup now. Our intention is to take the readings of this table. Means that in this ZPF test we need to keep the voltage is constant, means that the per phase voltage is constant. Only the two variables is there. That first variable is the field current, and the another variable is nothing but it's a short circuit current in the phase, right? So for every reading we need to adjust the load in order to make sure that the voltage is constant, and proportionally we can take the values of field current and short circuit current. So this will be started by closing the DPSC switch there, and once you start the DC motor, the alternator will run. So now here also we need to measure the speed of the alternator. So we need to adjust the speed of the alternator to the 1500 RPM by adjusting this rheostat. So once we are getting 1500 there, we need to adjust the field regulator of the alternator, so that we can see that the variation of the voltage. We will fix the voltage at some value, say it is 230 volts. is 115 now. So actually we are measuring on 150 scale, but it is connected to the 300 range. So we need to take multiplication of 2 so that 230 volts will be getting here voltage. The next step is to vary the inductive load. Once you vary the inductive load, let us see here. Now currently we have a 2 amperes is short circuit current, 0.4 is my field current. So this, let us say this is my first reading. So next I am adjusting the inductive load so that my current is varied to 3 amperes, the short circuit current, and the field current is 0.4. Now at this stage, if you observe, the voltage is reduced. So now we have to increase this because we need to make it constant, right? Now this is made constant and it is a 0.42 around, then it is 3.1 around. Because by the variation of voltage, small variation is observed in this, but also we need to take it into account. Again, the load is increased. So next I increase it to the current value to the 4 or 4.1. So now we can see that at a constant voltage we have a variation in the field current. Now it is 0.45 around. So still you can repeat the same procedure until the value of rated current 6.4. So you can stop the readings and stop the test after this 6.4 amperes of current. So once you got all the values for the variation of field current and short circuit current up to 6.4, you can make at that time for every reading the voltage is constant. So by all these three values, open circuit test, short circuit test readings and these readings, you can able to draw these three curves, first curve, second curve and this one. Then after this we can able to draw the Portier triangle. Once you draw the Portier triangle, we have some small calculation. So by this calculation we will be able to get the percentage regulation here. So this is the procedure. So here also we are measuring the percentage regulation. This is advanced method of measuring percentage regulation compared to the EMF method. And we have a ASA method also, that is also an advanced method. So this will give some high accuracy as compared to the synchronous impedance method. Hence we are preferring currently this test method for determining the percentage voltage regulation of the alternator. Thank you.